So now let's talk about sample size for proportion test. So when you use proportion test, you are comparing what proportions, success rates between groups, or you are testing proportion differs from known value. Or if you have binary outcomes, yes or no, success and failure, then you use proportions. You can also get the proportion sample sizes. For example, now vaccination efficacy, infected versus non-infected, treatment success rates, survey responses, agree versus disagree, diagnostic test accuracy. So the two groups have different proportion of success. So group 1 is 60% success rate, group 2 is 40% success rate. Are these significantly different? So the proportion in group 1 is P1, proportion in group 2 is P2. So significance level usually what's alpha and power is 1 minus beta. So these are the parameters you provide when you want to get your sample size. Then your effects, this is how you now calculate the coherence H. We use coherence H, not coherence D in terms of proportion. So for 0.2, you have a small effect, 0.5 medium effect, 0.8 large effect. So coherence H accounts for the fact that proportion near 0 or 1 have less variability. And this is the formula for calculating the H value. So for one proportion test, does the sample proportion differs from the known population proportion? This is a research question. So for example, now vaccination rate can be 70%, in your community can be 65%. So is this significantly different? You are going to see whether that of your community is different from the national vaccination rate. So you have to calculate your H using the formula I showed earlier on. Your P naught is your null hypothesis proportion. You have the significance level and you have your power. This is your P1 minus P2, the various values you have, and you approximate N per group. So you can see 0.05 at this particular difference. Then you have a large sample size, 0.10, you have 393. When you now go to 0.3, you have 45. So the higher your P1 minus P2 difference, then the lower your approximate N per group. So detecting small differences in proportion requires large samples. So when proportion are near boundaries 0% or 100%, the variance is usually what's smaller. And the implication is this: you may need smaller sample sizes when your proportion is actually near boundaries 0% or 100%, but harder to detect differences and is more sensitive to assumptions. For example, you're comparing 95 versus 90% success rate. It means you require fewer participants than 55 or 50%. So anytime your proportions is near a whole value, let's say 0% or 100%, the variation is smaller and you just need small participants to detect any significant difference. So you need a smaller, compare to have your proportion 55 versus 55 or 50%, for example. So proportion are usually discrete, but tests use continuous approximation. So you apply continuity correction when your expected cell counts are usually small, less than 5, or your proportion are very close to 0 or 1, or you have a small sample size. So most power analysis functions include options for continuity correction. So this is a situation whereby you have expected cell counts that are small, or your proportions are very close to 0 or 1, or you have small sample sizes. So this is where you now use continuity corrections or continuity approximations. So practical examples of proportion tests. So this is an example: does a new drug reduce infection rate from 20% to 10%? You can see your P1 is 0.2, your P2 is 0.1. So the difference is going to be what? 0.1, this minus this. So you calculate your H and your required N using the formula. Though you can use R for this, you don't need to calculate the formula manually. So the men and women differ in vaccination acceptance. So the estimated P1 and P2 from the pilot or literature. Then use your power analysis for your two proportion tests. So we have the McNemer test. So this usually used for before-after comparison with binary outcomes. So this is more or less similar to the paired we have earlier on. So we have before training 40%, after training 60% pass application. So these are the same individual tests set twice. So these are like an alternative to that particular paired sample test we talked about, but this one is for binary outcomes. So it also requires a different power calculation approach. These are some of the key takeaways. Use coherence H for effect size in proportions. Small differences need large samples. You consider proportions near boundaries. You account for match or pair designs, and you always plan for attrition. So using t-test formula for proportion data, proportion usually have different variance structure. So don't use t-test formulas for proportion data. You have to use the right formula for it.